Hi, everybody. Looks like I scared off a couple of people yesterday. It was almost full. Let's see, maybe people come a little bit late. So this talk, we're going to take an existing code base and see it fail on Java 9, and then eventually see it work on Java 9. And the original plan was to also create modules later. But I gave this talk before, and I realized that if I do the first part too quickly, then people kind of miss out and don't get all the details. So I decided to just do the first part. This is just about taking an existing application and making it compile, test, and run on Java 9. We're not creating any modules. If you want to create modules, that would be the second step, and I won't cover it in this talk. You can find the slides online at slides.codefx.org, and the demo code base is also online at GitHub, so you can play around with it yourself. That being said, this demo code base is of course made to fail as spectacularly as possible. So don't expect to see all of these problems in your project. Maybe other ones though. Before we come to that, I want to make a quick recap of the module system. I did the same. Who was here yesterday in my talk? A few, okay. So let me still repeat the Java module system basics for the rest. This is not a slow introduction. I assume you know most of this. I just want to refresh it. So jar hell is not good. Jars are bad. Jars have no names that the JVM cares about. They cannot express dependencies. They have no API that they can define. There's no concept of versions. And we've been used to this, but it's not ideal. So now modules were introduced in Java 9. They have a name that the JVM understands. They do declare their dependencies. They can declare their proper API and encapsulate the rest. And important, we still don't have any versions. So if you are hoping to finally be able to run 2 versions of Guava at the same time, then this won't be easier than it was before. And these modules were introduced to reach 2 important goals: reliable configuration and store encapsulation. There are more goals, but we'll be focusing on these 2. What turns a jar into a module? The jar itself is just as it used to be, but in there you have a module info class which gets compiled from a module info Java. And this is an actual module declaration from the Java SQL module. If you've been here yesterday, you already know what the transitive means, but if you don't worry, you can ignore it. The requires part is important, then uses block, we will ignore that as well, and then exports. So requires and exports, those are important. Let's look at requires first. This is part of the reliable configuration goal. Every module declares which other modules it uses. And when the module system comes into play, for example, when you start compiling or when you launch, then your module system will make sure that all modules are present. All transitively required modules are present. There must be no ambiguity. If you have 2 jars that claim to be the same module, then this doesn't work. For example, you can have no static dependency cycles. So you cannot have one module that declares A declares it requires B, and B requires C, and C requires A. That won't work. And you cannot split a package. We'll see later what exactly that means. The second part is store encapsulation. The Java SQL module declares explicitly which packages it exports. So it's important to see here it requires, you will see module names on the right side. So java.logging is a module name. Oh, semicolon is missing, I see right now. And exports a package. So both look the same, right? It's just a dot separated name, but by exports is packages. And Java SQL apparently exports a package of the same name, the JavaX SQL package, and the third one. So what do these exports mean? When you want to use a type from the Java SQL module, let's say result set, then result set has to be public. And this is normal, we already know this part. And the 2 other steps are new in Java 9, or the 2 other requirements. Java SQL, the module, actually has to export the package containing the type, the Java SQL package, which it does, great. And then your module needs to read Java SQL, which typically means your module has to require Java SQL if you are creating a module yourself. And that was reliable configuration with requires clauses and store encapsulation with exports clauses or directives. And this module system is basically built on these 2 mechanisms. It's not that complicated. The basics are not that complicated. And this was used to separate the JDK itself into modules. And you're not supposed to, really gather any valuable information from this. It's even outdated because the compact profiles are no longer modules. They used to be, but they're not. So it's just to see that the JDK was split into modules, and these modules require one another. And because we just looked at SQL, you will see it here. Here's SQL, and it requires Java logging down there. So you can see that this is module graph or readability graph shows the dependencies between the modules. Okay, so what I just talked about was the purely modular world. If we were in a world where everybody had modules. We're not in that world though, right? So, first the other features, sorry. Other features of the module system which I introduced yesterday, if you're interested in them, most of them at least I introduced yesterday. Have a look at that talk. So, what I was saying, what I just told you about is the plan for a fully modularized world where everything is a module, but we're not there yet. The Java development kit, the JDK, was modularized, and your program is running on top of that. But yours doesn't have to be modularized. So somehow jars, legacy jars, so to call them, or plain jars, jars without a module descriptor, have to cooperate with the modularized JDK. So from the point of the module system, everything has to be a module. But for compatibility reasons, the class path must still work. So there's obviously like a collision. Some of these things don't work together. And the solution is the unnamed module. Every class loader has one unnamed module, which means if your application doesn't do any fancy class loader magic, then you will have only one unnamed module that you care about. And all the jars that you put on the class path will end up in this unnamed module. It has a couple of special properties. First of all, it has no name, which kind of makes sense. The reason why the unnamed module has no name is that you cannot use it in other module declarations. You cannot require the unnamed module, for example. But the unnamed module can read all other modules that are running. So that means code from the class path can see by default all code in the JDK, all exported code in the JDK, which makes sense. And because the unnamed module does not have a descriptor, it cannot declare what it exports. So it just exports everything. The important part is that the unnamed module, so all the jars end up in one module. So it ends up as one monolithic blob or one ball of mud, the same ball of mud that we're used to actually when running from the class path. So the so-called chaos of the class path lives on within the unnamed module. So now let's have a look at what this means for migrating to Java 9 and what other changes were made that might cause you problems. So we're going to go through these problems now, and then I'm going to switch and we're going to show you the application, and we're going to encounter some of these problems and apply the fixes that we talked about here. There are some internal changes in the JDK that can break your code. And once again, this can happen just by running on Java 9, even if you don't create any modules yourself. The first and most obvious one are internal APIs. All APIs that are in sun.star packages or most that are in com.sun packages were never meant for public use. So there's a Oracle team sometimes shows this slide where they have like with the Wayback Machine, they went to a Sun page from I think end of the 90s even, where it says like everything that's in sun.something you should not use. So this has been common knowledge, but we still ignored it, right? Because it works. So if you have a problem and using a sun misc something class fixes it, you're going to use it. So people used it, but that doesn't work anymore. So internal APIs are encapsulated by default. At runtime, they were made accessible on Java 9 to give you a little bit more time to make your code work. So that was one of the later decisions in the Java 9 development cycle to give you more, make it easier to migrate to Java 9. And some critical APIs like sunmisc unsafe may even survive a little bit longer than Java 10 or Java 11. Remember, Java 10 and Java 11 are both next year, right? So these won't be around for another decade, but they will be around for another year or two. So how do you look for code that uses these internal APIs? You can use JDevs, which is a great tool. It was introduced in Java 8. If you don't run Java 9 So if you don't have Java 9 installed, still download JDK 9, use JDips from JDK 9, because it works a little bit differently. So you can use it, for example, to report use of internal APIs. So ignore the rest of the command line. The important part is JDips and then -- JDK internals. And I use this on some project, and then it tells me that, for example, badtechcodec.jar uses a removed internal API. And Guava uses JDK unsupported, the unsafe class. So you get a report. And the important part is not only for your code, but also for the code you use, which is really important because your manager won't care whether your program failed because of you who did something wrong or because of your dependency who uses unsafe. So it's important to analyze your dependencies as well. So what else should you look for? JDips only statically analyzes code. It will not find problems due to reflection. So look for code that uses something like class for name or uses set accessible. These set accessible calls will cause problems. And this means you will also have to check your dependencies if you want to be thorough. Or you just run them in your integration test and you'll see whether something fails. So what you do, you fix your code if it's your code. If it's not your code, you have to contact the library developers, open an issue, and then the next step would be maybe look for alternatives. So if you've been using a JDK internal API, chances are there is an alternative, and JDips will even report them. If all of that fails, you can use command line flags to force the module system to give you access to some of these things. Okay, that was internal APIs. Second problem, split packages. Every package should have a unique origin. Every package should only belong to exactly one module. And no module should read the same package from two different modules. The current implementation is so that no two modules are allowed to even contain the same package. So this is called, if it happens, called a split package. So if one module has a class in org foo, has a class foo in the package or company, and another has a class bar in the package or company, if both of these are modules, then that won't work. It's called a split package. The interesting thing is that this behaves differently if part of the split is across modules or between a module and the class path. If the split is between modules, then the Java command will tell you at launch time or at compile time that you have a split package, because it scans modules. It does not scan the unnamed module, because the unnamed module contains all this legacy code and is not fit to be scanned anyway. What happens there, and that can be very confusing, this is the most complex problem you will likely encounter, is that the class path portion of a package split becomes invisible. We see that in practice later. So a class that is on the class path is not being loaded, and the class loader complains that it couldn't find it. And then you look at the class path and you're like, but it's there, what went wrong? Maybe this went wrong. So some examples, why would anybody split packages? A lot of examples are, for example, the JBoss modules. Then you can find some like XML APIs, which split a Java XML package. And the most problematic case is JSR 305, as we'll see later. It splits the JavaX annotation package. JDips reports these as well, so if you're looking for them, just run JDips, and it will report split packages like so. So what to do? There are a lot of options, but most of them really fall into two categories. The first one is fix the actual problem, which is like the first part, which you can do if you have control over the artifacts. And the second one is you can't really fix a problem because it's maybe a library that you're using. What you can do then is you can either replace the module with the jar, which you can do which you could do in Java 8 already with like an endorsed standard overrides mechanism, or, and this is like the solution that always works and is the most hacky, and we'll use it later, is to patch a module. You basically say, like, take all the content from this jar and stuff it into that module and make it work. Internal APIs, split packages. Third problem, Java EE modules. So Java EE isn't Java EE anymore, it's now EE4J. Oracle wants to get rid of the remains of Java EE APIs that are in the JDK, and it put them into these 6 modules. You can see which packages they contain. And these modules are deprecated for removal. So in some future version, I guess sometimes 2018, they will be gone. And this is the more immediate problem, they will not be resolved by default at the moment. That means, as I said earlier, the unnamed module can see all the JDK code. That's true. All the Java SE JDK code, not the content of these modules. So if you run JDEPs to tell you what modules you depend on, then you will see a list like on the right. And the Java used here depends on Java base and data transfer and desktop. And if it were depending on a Java EE module, it would be listed there. So I can just scan the list of modules and see whether I have a Java EE module in there. Or I just try to compile and run the code. I get an error message, as we'll see later. So what should you do? The proper long-term solution is to pick a third-party implementation and use that. What we'll do in the talk later is we'll use add modules to add the module, the deprecated module from the runtime, and make sure that it is part of our part of the module graph as we run the application. Next problem you might encounter. We're getting into more weird areas here. So the first three, I think, are fairly reasonable things that you could have done, that you could encounter. Runtime images and the other parts that I'll tell you about a little bit weirder, but nonetheless they happen. So the JDK and JRE got a new file layout. And I've seen code that actually tries to rummage around in the JDK folder and look for a bin folder, so to find the Java C command in there and stuff like that. And such code is highly likely to break because the folder structure was changed. Furthermore, what used to be jars, like RT-jar and tools-jar, is now split into JMods, which is another way to deliver modules. And most tools won't work with that. So if you have an old IDE, it won't work on Java 9 because it goes looking for tools-jar and won't find it, and then that doesn't work. Then the application class loader is no longer a URL class loader. We'll see what that means in the demo later, but this can actually cause problems if you have like a custom-built plugin system. You might have cast the class loader, URL class loader, that will fail now. And if you've used URLs to look into runtime images for resources and stuff, then this URL schema changed. So if you build these URLs yourself by hand, then that won't work. If you just take a URL from one API and give it to the next, that works. But if you take them apart manually or put them together, it will likely fail because they changed the way they look. So what do? You look for code that does the things I just told you about. Particularly a URL class loader, you can look fairly easy. Just do a full text search for the cast to URL class loader and you should find them fairly easily. Then there are a bunch of things that are obsolete and no longer work. Compact profiles were introduced in Java 8 as a step to have a smaller runtime. You can do that in Java 9 directly now, so we don't need them anymore. The next three mechanisms, I never used them. You could use them to replace some things in the JDK in the JVM when you booted it. And the last one, you could launch the installed JRE, let's say JRE 8, and tell it, please run with version 6, and then would go looking for an install of a JRE 6 and launch with that. And that doesn't work either. And yes, there are even more small things that can break. So I wrote a blog post about that, and a few other posts that give you some background information, like how to use JDEPs, how the command line options, which ones are going to help you, and how you can plan all of this. What would be some good steps to do some reconnaissance into enemy territory, so to speak. Collect some data and then have a look where you are. Go to slides.codefx.org and then click all the links. Also, last thing has nothing to do with the module system, but the version strings changed how they look. Oh, this is old. It's not 18.3. We now know it's going to be 10.0. So this also had nothing to do with the module system, but still fails on Java 9. For example, log4j1 parses the version and makes some decision based on the version. And what it does, it says, well, throw away the 1 dot, because we know versions start with 1 dot, and then take the next number and make a decision based on that. And of course, that fails now. Okay, so my general advice would be, these are the most relevant problems, and I told you how to go look for them. JDEPs is a great tool to get you started, give you a lot of information. And then if you're thinking about updating to Java 9, let's say you want to do that in the long term, but you don't have time for that right now. The first thing you can definitely do is with the problems that I just showed you, have a look around in your code base, start updating parts that might cause problems, but particularly update all your tools and all your dependencies. So many things might break, many old versions might break on Java 9, and all of the big frameworks will release versions that work on Java 9. So if you make your update now to the most up-to-date version, it will be easier for you to make an update to a Java 9 compatible version when it comes out. For example, if you're not yet on Spring 4, so you could prepare to make an update to Spring 5, which is Java 9 compatible. And the last thing is the easiest one. Just download Java 9 and see what fails, what breaks. That looks like the slide I just showed you, right? Okay, let's go there. I plug my book later. Let's start with the application. So what I do now, I prepared an application. It's a very simple one. I won't even really tell you what it does. If it runs, it exposes a REST endpoint, and I can use that to query some information. And everything else is not overly important what precisely it does. So I want to show you that it works. This is a little bit weird for me because I'm looking at my monitor down there. So I can copy-paste stuff from here to there. Let's see how that works. So what I can see is where I tap to. OK. Can you reach that? Should I increase the font size, or is that OK? OK. So I just started building the project on Java 8. And it looks like it's working. Everything is green. Success. Let's launch it. No. See, there we go. Good thing I can copy-paste this. OK, it starts. So what does it do? We start the application. I've copied all the files to all the dependencies to these folders. Then I launch it, and then it lists the class path content for some reason. And then it goes on and does its thing, blah, blah, blah. It reports some data, and after 10 seconds, it's done. While running, I can curl this endpoint and see that I get something back. There we go. No, we don't. No. OK, I think with watch. Live demo fail. Awesome. Oh, yeah, I know why, I guess. No. Why are you failing? Oh, you're not. OK, great. Now it works. So what I'm doing now, I'm going to leave this open. It queries the endpoint every second and shows the result. So now it shows the results, and as the program is done, the system is done, it says connection refused. OK, so this was Java 8. Let's have a look that I've not been lying. MVN-V says I've been running this with 1.8. Oh, there's a noticeable delay. With 1.8 something. So now I want to take this and make this work on Java 9. First question, how exactly do I do that? So I would not recommend downloading JDK 9 and make it the default install on your system. If you're using other Java desktop applications, they might fail. So what I usually do is I generally have symlinks that can write Java 9, for example, so then I can run the Java 9 command. And for Maven, what I found to be useful is to run the entire Maven process on Java 9. And there's an easy way to do that, actually. In your home directory, there's a file Maven RC. And, oh, great. OK, you can see it up there, great. So there's a Java home variable that you can set. So now I set it to Java 9. And now I query Maven, and it should report that indeed I'm running on Java 9 now. OK. So next thing we want to do, we could already do Maven clean install now. But if we do that, we would still compile for Java 8. What I would recommend is to compile to Java 9, but do that in a way that does not impact your regular build, which for Maven means you would create a profile. So let's go to the parent POM. You can see the project here. There's a couple of modules, and then you have, so like Maven modules or IntelliJ modules, not JPMS modules. So here's a parent POM, and you can see that we're building for Java 8 at the moment. So what I recommend is if you start building on Java 9, try to leave the regular POM mostly untouched unless you maybe update dependencies, but don't put all the add modules and the other command line options that we're going to use later into your main build, because then it won't work on Java 8 anymore. I would try to work towards having one branch, most likely trunk or master, that gets built both on 8 and 9. And to do that, now we're going to create a profile. So we're going to create a profile that we call Java 9. It activates automatically if it runs on JDK 9. And then you just put in stuff here. Now I can just configure my build in here, which in this case means I want to set the release in the profile. There we go. So now I set the Maven property, I set the Maven compiler release, that's new. You don't have to set source and target separately, you can set release with one flag. I set release to 9. So that means when we run on Maven on Java 9, we actually use source and target as 9. Okay, so that sets up the build. Now let's go try it out. Maven clean install. Of course, I'm expecting to fail. Takes a moment. Oh, sorry, I scrolled. Oh, there we go. So what happened? We were building the project utils, and while building utils, we could not find the base64 encoder, which was in sun.misc. Okay, if you paid attention earlier, you might think, sun.misc, I know what the problem is. The problem is that it's encapsulated. But that's not true. It's gone. Base64 has been deprecated, not deprecated, but there has been a replacement for a long time. So the base64 encoder class, is gone. Luckily, it's very easy to find to replace it. So let's see which class is this. The utils class. So let's go to utils. There we go. And we see the utils class, and down here, it used the base64 encoder, which we're not supposed to do anymore. So we use the official class, which is base64 in java.util. Now, also we have to remove the import, and then we should be done. Let's see. Okay, we passed the compilation phase. That's great. And then we ran the tests, and then we see these strange warning blocks here. An illegal reflective access operation has occurred. So apparently byte buddy used some, oh my god, this class used some, accessed the method javalang class loader, loaded class, and then please consider reporting this, blah, blah, blah. So what happened here is byte buddy used reflective access to gain access to an internal API. Internal APIs should be encapsulated, right? But as we discussed earlier, at runtime, they are still exposed to make sure that stuff that shouldn't actually work still works for another few months or maybe even a year. So, but the module system warns you about it. So if you see these blocks, it tells you that something is doing something that A, it shouldn't, and B, will stop working at some point in the future. So it shouldn't do that anymore. There are several ways around this. First of all, I want to tell you about the illegal access flag, because this is actually configurable, this behavior. What we see here is that we get one warning on the first access to that package. There are several other ways to configure this. You can say, I want to be warned each time an access occurs. I want to get the full stack trace, or I even want to deny this. So let's do the latter for a moment. So we're gonna go back here. Now we're in utils. There we go. Here's the POM. I'm gonna go to the pen prompt. Because I'm lazy, I'm gonna copy paste this all over the place. So this is the POM for the project that just failed. And what I want to do here is I want to reconfigure the build just for Java 9. So I paste this again on the wrong place. Here you go. So this block is the, if you're not terribly familiar with profiles, don't worry. This block is just the normal block, right? Build, plugins, plugin, and you can do similar things with Gradle. So what you're doing here is like just a normal configuration, but you make it specific to this profile. And what happens here is we say the Maven Surefire plugin, which is the one running the tests, you want to do something here, but let's not yet add opens. I will show that in a minute. Let's start with something else. Let's go with arcline, illegal access. Oh, did I mistype? Oh, that looks about right. Let's deny illegal access. Bam. So now the build fails as expected, and we basically get the same message as before, but it's no longer a warning. Now it's an exception. So, but we want to fix the problem, right? Now we broke the build even worse. We want to actually fix the problem. We can do that by opening the package. So what we do here is we tell the module system that the Java base module should please open its Java lang package to all modules, including the unnamed one. And with these kind of command lines, you can influence which modules are in the graph, which other modules they read, which packages they export, which packages they open. So if you have control of the command line, you can get around a lot of the module system limitations, which means as an end user, you have most of the power that you need, unless you don't have, sometimes you deploy an application, don't actually have control of the command line, but usually you do. As a library developer, though, you have more problems. You can, of course, tell your users that they have to use some flag or another, but the better solution is to, find another way to solve your problem and not have your users do this. So let's see what that opens. Oh, sorry. I usually use the drop-down console, so terminal. Okay, I shouldn't clean all the time. It just takes necessarily long, but it's reflex. Okay, so now it works. And it also works without the warning. So two things happened here. The first thing is I used add opens to open the package, which means the warning is gone. I also used illegal access deny to deny further reflective access. I think this is a good configuration. When you're looking for a way to make your stuff work on Java 9, I would recommend to use all of these escape hatches that you need, all the add opens, all the add exports to make it work, and then put in the illegal access deny to make sure that your build breaks when new problems crop up. And then you can set out and look for long-term solutions without these new flags. So the long-term solution in this case, by the way, which makes basically everything we just did moot, is to just use the current version of ByteBuddy, which is the parent. So the problem here is ByteBuddy, which is used by Mockito, and if we just update Mockito, then, oh yeah, that one, exactly, then the problem is gone, because Raphael Winterhalter, who does ByteBuddy and also works with Mockito, is on the cutting edge, and he solved this problem already a couple of months ago. So this is the proper solution. If your dependency does something it shouldn't, go first look at that dependency, do some search, look for GitHub issues. Maybe they already fixed it. So this is the best solution out there. Just use the updated version. Okay, so now we're done with this project. Well, let's drop the clean for once. Yeah, maybe not. Because I built all this in preparation, of course. So if I just do Maven install, maybe it just does nothing, and then it just works. So let's see what breaks next. Ooh, that's quite a lot. So the message, so first of all, the class that makes trouble is statistics entity. We'll look at that in a moment. And then what we'll see here is the package Java XML bind annotation is not visible. Okay, so that is a problem. We don't see this package. And the reason for that is that that package is in one of these Java EE modules that is not resolved by default. So let's first go into statistics entity and have a look at that class. And you see here that it indeed uses the generated. It uses the generated annotations, and this one comes from the module java.xml.bind. If you ever encounter a problem and you don't know which module a class comes from, the JavaDoc is there for you. This is the Java 9 JavaDoc, and first of all, notice in the top right corner it has a search field, which is just awesome. So we go to generated, and then it says which module it comes from. Oh, so wait, no, don't go down that road again. Okay. Okay, let's switch order. Let's continue here. So I was mistaken. So wrong module. So it comes from this module, actually. Okay, that's fine too. Let's see where we go from here. So now we know which module this comes from. So now let's see, we looked at generated. Let's go to the module descriptor, sorry, to the POM belonging to this project, which is this one. And let's include one of these profile blocks again. So we can configure the build to work here. So what we have to do is we have to add the module. So we do the same thing as before. We create this profile. Now let's see. Yes, right spot for once. In the build plugins plugin, compiler plugin, we tell the compiler to add the module, what was Java XML WS annotation, right? Okay, oh. Now, which project failed? REST. Let's build this. What I expect now is less error messages. Ideally, there would be no more error messages, but I already know that some of them remain. So more problems. I just pick at random, not totally at random, but I pick one of them, which, let's say this one. The package javax XML bind annotation is declared in the module blah. Oh, sorry. Which is declared in the module Java XML bind, which is not in the module graph. So usually what will happen if you do not have if you use a Java E module that is not resolved, usually you get a hint which module the package comes from. I will show you later why this didn't happen in this case, in the first case, but in the second case it happened. So we apparently used the Java XML bind annotation package, and it comes from this Java E module, which is not in the module graph, and we already know how to solve this. We just add it here, add modules. You can add several modules, of course, as the name suggests. So now we add a second module. It's a reflex to use that. Should probably remap the hotkey for that during these talks. Okay, now more errors disappeared, right, but there are still a few left. So what we did now, we saw two Java E modules that we were using that we had to add manually to make this work. Now we come into the split package scenario. This is as I said earlier, probably the most complicated problem you will face. So what it says here, it says the class non-null from the package javax annotation could not be found. And that is weird, because non-null, you know, it's like the JSR 305 annotation that many people use from findbugs. Why would it not be there? I mean, we're pretty sure it's in the Maven POM, and if you ask Maven to run, to run with full debug output, then you will actually see it here. This is the class path here, and now we have to spot it. I know it's somewhere here. There we go. There it is. So the jar is on the class path. and still the class is not found. And this is exactly the split package case I talked about earlier. The JSR jar, JSR 305 jar, delivers something that is in the JAVAX annotation package. I think that was in here. So the non-null application comes from the JAVAX annotation package. But the JAVAX annotation package is also in one of the JavaE modules we just added. And now we're in the case that when we load a class from that package, the module system knows, I know which module it's in. It's in that module over there, which claims to own that package. So we go to that module and ask it to load that class. And then the module says, I don't have this class. And then loading fails. And the class path is not checked. This looks like a weird oversight, but actually the JSR jar is something that is really, really not supposed to. I think it is not even, well, people tell me, I didn't check this personally, it's not even technically legal because the license declares pretty specifically that you're only allowed to deploy artifacts or to create artifacts that use the Java and JAVAX packages if those classes are standardized. You cannot just randomly use these packages. You will get in trouble with Oracle, apparently. Anyway, what do we do now? This is the most complicated solution. We can use, as I said earlier, we can patch a module. So what that means is we tell the Java module system, tell the module system to take the stuff that's in the JSR jar and stuff it into the other module, namely into the module that owns that package. So we can easily check in the Java doc which package that is, and it's this one, the one we added at first, Java XML WS annotation. That's the module. So what we do now, we say patch that module with this class here. Now you have to find a way that points at your jar. This is not a terribly good way to do it. It's the best way I found to make it, to take it from the Maven repository. You could possibly also deploy the lib in your project or whatever. So there's several ways to do this. But what you're basically saying is you have to know the path to the jar and then add it, add all the classes to the module. Great. Remember how I told you that this is great new flag called release? Yeah, release doesn't work. Oh, invalid flag. Sorry, no, that's not the problem that I was expecting. Is there a new line here? Oh, what the hell? That's not supposed to happen. Oh, sorry. More new lines? Apparently there are line breaks in the PDF which I created. So maybe now. Yes, now we get the error expected. If you use the new release flag, you cannot use patch. Like, I don't know, I don't even, whatever. At this point I was like, I'm just going to do whatever you want me to just make this work. So remember that we used the parent POM to be very clever and create release down here and not use source and target. Yeah, well, now it's source and target again. Now, finally. Okay, so let's build the entire thing. So we just solved the three most likely problems: internal APIs, JavaE modules, split packages. You've seen how to do that. Now the build should work. And now we can try to run this. Oops. Class cast exception. Some class loader, app class loader could not be cast to URL class loader. Oh yeah, remember I told you about that. So where is this? In main. Let's go to the infamous main class. Log class path content. Remember in the beginning you saw the class path content? So the only way to do that is to cast the class loader to URL class loader. and then get the get URLs, because that method does not exist on class loader, and then create a string that you put out there in the beginning. So this is of course a kind of benign use of the URL class loader. Another way how people use this is to get the URL class loader and append the class path at runtime. At runtime they say, look, this folder also belongs to the class path, and this folder also. This doesn't work anymore in Java 9. There is no way to append to the class path or the module path of the system class loader. What should have been done instead, not for this specific use case, but for the use case that you want to add new jars to the class path, was to create a new class loader with the new path. So in that case, you might have to restructure your application. In this case, I'm afraid there isn't a good solution. So it didn't look very long, it's just a demo after all, but I didn't find one in the 5 minutes of research. This simply won't work. So we have to not use that part of the application. Usually this shouldn't be a problem, but maybe your application depends on one of these small details, which is the reason why some problems might be very frequent, but might not be the important problems. Like I basically had to add a couple of modules to each of our 400 jars. So each of the build process I had to add the same couple of modules. So this problem was very frequent, was not a hard problem to solve. If your critical part of your feature set depends on the URL class loader, well then could be a problem. Java JAX-B exception is not found. We added the modules at compile time. That did not really change the code. The fact that we need that module is not magically encoded into the jar. We have to do the same at runtime. So now we had to add the same modules again. Almost the same modules. We don't actually have to do the exact same modules because there are many of the annotations have compile time retention, so they're not visible in the code anymore, so we also don't have to do the patching thing. But generally speaking, you will have to you have to add the same kind of flags here that you had to add during compilation. Now it works, and even the REST endpoint works, and we're very happy with that. Nice. So, that made everything work. Back to the slides, which is also the last slide. I want to say a few words about myself. So my name is Nikolai Parlog, and I write a blog at codefx.org. I do a lot of other things as well. I started a YouTube channel, which is really barren at the moment, but I'll start doing stuff in the next couple of months. And you can follow me on Twitter. And if you want to learn more about the module system, about all the problems I just told you, but also about how to modularize your application, like how to turn it into modules, the basics, the advanced features I talked about yesterday. If you want to do any of that, then this is the right book for you. It's available as MEEP, which means you can get the electronic version of the first 2 parts. The 3rd part is still in work, and I hope you get a paper version early next year, but I won't make any promises to when exactly that will be. So, thank you very much.